Alright, so today's goal is multiplying and dividing radical expressions. So, it says simplify each completely. Okay, so neither of these two are perfect squares, but I can break this one into square root of 4, square root of 2 times square root of 4 and square root of 3. So this is 2 square root of 2 times 2 square root of 3, which is 4 square root of 6. So let's take a look. See how square root of 4 is 2, and then you still have square root of 2. Square root of 4 is 2, you still have square root of 3. Then I multiplied what's outside. 2 times 2 is 4, 2 times 3 is 6. Okay? So here now, this one gets nice. It's just 4 times 5, 20. Now, square root of 13 times square root of 13, well, that's technically square root of 169, which is 13. But if another way to look at that is, it's the square root of 13 squared. So it's just 13. So I look at these. I can't simplify anything yet, so I have to multiply it out. So 5 times 15, 75. But then that I can break into 25 and 3. So I get 5 square root 3 plus 4 square root 3. So I have 9 square root 3's. Okay? So let's talk about this here. So look, see up here, see how I multiplied and multiplied underneath, but you don't add underneath. It's not 3 plus 3 is 6. It's I have 5. How many square root 3's do I have? I have 9 square root 3's. So yes, you can multiply, but you can't add, okay? So here, now see how they're both under fourth root? That's good. That means we can multiply them. But I want to think, can I simplify anything first? But there's nothing you can simplify first, so you just multiply it out. You get fourth root of 162. Now, I don't know the perfect things of the fourth, but I do know 2 to the fourth is 16. 3 to the fourth is 81. So if I did 162 divided by 16, it gets me a decimal, so that's not good. So if I do 162 divided by 81, I get 4th root of 81 and 4th root of 2. Well, the 4th root of 81 is 3, so you have 3 4th root 2. Okay? Now here, the problem with this is, next problem here, problem with these, you can't have radicals in the denominator. But since these are both underneath the radical, before you go any further, simplify this. It's going to be 8 over the square root of 6. Then you got to multiply by square root of 6 over square root of 6. So you have 8 square root of 6 over 6, which is 4 square root of 6 over 3, because you can simplify the fraction. Okay? Let's keep going. So again, see how these are both underneath square roots? So that's like looking at it like this then. Square root of 8 over 24, which is square root of 1/3, which is 1 over the square root of 3. So now that means you got to multiply by square root of 3 over square root of 3. So you get square root of 3 over 3. Now here, see how square root of 13 and square root of 13 are there? So that means cross them out. So you have this, square root of 7 over square root of 3. So again, multiply by square root of 3 over square root of 3. You get square root of 21 over 3. Cannot be simplified, so we're good. Alright, let's keep going. So now we got to see if we can multiply and add still here. So again, we got to distribute this out. So square root of 5 times square root of 5. Well, 5 times 5 is 25. What's the square root of 25? 5. Plus 5 times 20 is 100. What's the square root of 100? 10. So you get 15. So again, we had square root of 25 plus square root of 100, which is 5 plus 10. Okay? So here, just like when we dealt with quadratics, you got to go distribute everything. So that's 3 minus 4 square root 15 plus 2 square root 15 minus 8 times 5. Okay, now that one might be a little tricky, but the 2 times negative 4 is the negative 8, and then square root 5 times square root 5 is 5. So you have 3 minus 2 square root 15 minus 40. So that's negative 37 minus 2 square root 15. And we are done. Okay? Now remember, this just means that we're going to square it. So we just copy it down again. Get rid of the squared, but copy it down. Square root of 5 times square root of 5 is 5. Minus 3 square root of 5. Minus 3 square root of 5. Plus 9. So you have 14 minus 6 square root of 5. Because 5 plus 9 and negative 3 minus 3. Okay. Now we got to remember, think back to the exponents rule. What do we do when the base is the same? What do you do with the exponents? You add them. So this is just 5 to the 4/3. Okay? Here, what do? You subtract. So this is 5 to the negative 2/4, which is 5 to the negative 1/2, which is 1 over 5 to the 1/2. But that is 1 over the square root of 5, which we can't have. So you got to go square root of 5 over square root of 5. So that's square root of 5 over 5. Now don't jump ahead too quick on this one. Do the math inside first. This would be 2/3 minus 1/3 is x to the 1/3 squared. Power to a power you multiply, so it's x to the 2/3. Which, remember, another way would be cube root of x squared. Okay, let's keep going. Alright, so simplify by the conjugate method. Okay, so conjugate. See how this says, so conjugate, it's a minus the square root of b. The conjugate of that is a plus the square root of b. Or vice versa. So this one you got to multiply by 2 plus square root of 5 over 2 plus square root of 5. Now I'm going to show you the long way once, and then we'll see the shortcut here. So 3 times 2 is 6. 3 times square root of 5 is 3 square root of 5. 2 times 2 is 4. Plus 2 square root of 5. Minus 2 square root of 5. Minus 5. So that is, you still have 6 plus 3 square root of 5 on top. Now look, this is going to happen every time. What's 2 square root of 5 minus 2 square root of 5? It's 0. That's the whole point. You're getting it to go away. So then that's negative 6 minus 3 square root of 5. So with the conjugate, you really only ever have to multiply the first two and the last two, because the middle two always cancel out. Okay? So this one, the conjugate is going to be square root of 11 plus 2. Square root of 11 plus 2. So you have 6 square root of 11 plus 12 over 11 minus 4. So you have 6 over 7 plus, or 6 square root of 11 over 7 plus 12 over 7. Always separate it out to see if you can simplify it, okay? So here we have square root of 7 plus 2 times square root of 7 plus 2. Now here, be careful. The bottom, you can still just go 7 minus 4. You can still just do the first two and the last two. But see, these are the same. So you got to make sure you do everything for the top. So that's 7 plus 2 square root of 7 plus 2 square root of 7 plus 4. So we have 11 over 3 plus 4 square root 7 over 3. Let's keep going. So this one's just right in lowest terms, so this is what I'm saying. This is why we should always separate. Okay? So that's going to be square root 3 over 2 minus 3 over 2. Alright, let's move on. Alright, it says the area of a circular cross-section of a basketball is 70 square inches. The area enclosed by a basketball hoop is about 254 square inches. Find the ratio of the diameter to the basketball to the diameter of the hoop. Okay. Well, the area of a circle is pi r squared. So this is 70 equals pi r squared. So we got to get divide by pi. And then r squared equals 70 over pi, square root. So you get the radius is the square root of 70 over pi. But we want the diameter. So the diameter of the basketball is 2 square root 70 over pi. Now the hoop, you get 254 equals pi r squared. Divide by pi and square root, so you get r equals square root of 254 over pi. But then you have diameter, so it's 2 square root 254 over pi. Now it says, find the ratio of the diameter of the basketball to the diameter of the hoop. So that means we want to do the diameter of the basketball divided by the diameter. My apologies here, because it's not 70 times pi, it's 70 over pi, and this is going to be 254 over pi. So the 2's can cancel, and when you multiply by the reciprocal of this, so you have pi over 254, the square root of that, so those cancel, the pi's cancel, so really we have the square root of 70 over 254. Now we got to simplify that. Okay? So you get the ratio is square root of 35 over 127. And we'll just leave it at that. Okay. It says if the directions say to use pi equals 22 over 7, calculations will be a little different. Okay, so you got to make sure to read those directions. It says the width W and the height H of the strongest rectangular beam that can be cut from a log with diameter of 24 inches are given by W equals that, H equals that. Find the area of the rectangular cross section. Well, it's just W times H. So you get 8 squared 3 times square root. Now, you have to multiply these out. You can't just get rid of the squared. So that's going to be 576 minus 192. So 576 minus 192, and they want the exact answer, so you get 8 square root 3 times square root of 384. I'm going to try to simplify the 384 first. And you can change that to square root of 64 and square root of 6. So you get 8 square root 3 times 8 square root 6. So then we have 64 times the square root of 18, which is 64 times the square root of 9 times the square root of 2, which is 64 times 3 square root of 2. And then 64 times 3, 192 square root of 2. I will see you in class.